All right, this is the part 2 of the 3.2 notes for quadratic functions in vertex form. Today we're going to get more into the graphing side of things, but before we get started on graphing parabolas, I want to do a little reminder activity on graphing a line. So to go over, the equation of a line in point slope form is f of x equals mx plus b. You may have seen this before with a y equals mx plus b. Remember that they have the same meaning. It's just a different notation. So let's break down y equals mx plus b and talk about what we've got here. The b is the slope, okay? And slope is always equal to rise over run, right? Or change in y over change in x. And b is the y-intercept. Whenever I'm starting a graph, I always start here. This is my starting point. So these two things are essentially my different transformations that happen. So b is my slide up or down, and m is my slope, so it changes the steepness and direction. Similar to any type of function, but also to the quadratic. Now remember, if something is a transformation like m and b, then that means the rest of it is the parent function. So as a reminder, the parent function for a line is f of x equals x, or y equals x. So it gets steps there. To graph, the first thing that we do is identify the y-intercept, plot it, then use the slope to plot at least 2 more points and draw the line. Well, I've got a grid provided for us, but I don't have the axes drawn on there on purpose. Remember, when graphing, you absolutely need to use graph paper. So hopefully you've got graph paper in front of you, or a digital graph paper, or you've drawn vertical lines on your lined paper to create a grid. So I'm going to go ahead and I'm going to choose to just place my x and y axes kind of wherever I want. Sometimes I think about the problem and anticipate a good spot for them to be placed. Sometimes I just go with the flow and then figure out the rest later. Okay, so there's my x and y axes. Now I know this equation of a line is f of x equals mx plus b. This particular line is f of x equals 4x minus 2. So what do we got? I always start with my y-intercept. My y-intercept here is negative 2. So I'm going to start there. Y equals negative 2 means that from the origin, I'm going to go down 2 and make a mark. Now, when I've got my xy plane here, I have to come up with what scale I'm going to use. And you've got flexibility here. You don't have to use the same one that I'm using. You can still be right and have a different scale. When I'm talking about numbers like 2 and 4, I feel like that's going to fit just fine if I count each box to equal 1. So the first box is 1, the second box is 2, 3, and then 4, 5, and then 6. I tend to only write a number on every second box, just because it's less crammed, right? And then I might go to the left also. Okay, so I've got my initial point at x equals negative 2, and then I need to do my slope. So my slope, right, if I were to kind of, here's my slope, here's my y-intercept. My slope is 4. Whenever I'm performing my slope, I always want to do rise over run, so I want this to be a fraction. So I'm going to force it to be a fraction by putting 4 over 1. So I rise positive 4, that's going to be up, and I run positive 1, that's going to be right. So I go up 4 from my y-intercept. So up 1, 2, 3, 4, and over 2. Oops, I'm sorry, over 1. 4 over 1. And then up 1, 2, 3, 4 over 1. Now going up 4 over 4 is actually the same as going down 4, left 4. Because a negative divided by negative is still a positive. So if I go back to my y-intercept and I go down 4, 1, 2, 3, 4, and then left 1, you'll notice that that lies on the same line. So go ahead and use your straight edge, use some kind of a ruler, and draw a nice straight line. There it is. It has a negative y-intercept and a positive slope. Okay, let's do another. So I've got my equation of a line in slope-intercept form. So y equals mx plus b. This function we're calling g of x. I'm going to go through, identify my y-intercept and my slope. The y-intercept is the number that I add or subtract at the end, so that's going to be my 3. The slope is the number in front of x, so this time I've got negative 2/3. Before I start graphing, I need my axes. And I'll go through and I'll label my axes. Now, you don't have to necessarily go in every direction, but you have to put a scale on each axes. So it's not enough for me just to do that. Now, that's enough to indicate my scale for x, but not enough to indicate my scale for y. So I always have to mark both axes. And I like to mark a little bit more than that. I usually mark them like this. So I go to my y-intercept, y-axis, the y-intercept is 3, so I go up to 3. And then I perform my slope. So rising means I go up or down negative 2, so negative means I'm going to go down 2, and then I run positive 3. 1, 2, 3. Down 2 over 3. Now, it's also the same, negative 2/3 is the same as a positive 2 on top and a negative 3 on bottom. So from my y-intercept, I could go up 2, left 3, and you'll notice that that lies on the same line. You only need 2 dots to make, or 2 points to make a line. I like to use 3. When I'm drawing on this device, I use all of them because it's not quite as easy to get straight. So let's talk about some of the similarities and differences between these two graphs. Okay, so in graph A, I have a positive slope. It's going up to the right, and this slope is 4. This number is bigger than 1, so it's steep. When I were to draw a quick sketch of the parent function, right, I get a line that looks like this. It's at a 45-degree angle. This A, or this slope being more than 1, means that it's steeper. It gets bigger faster. When I look at B, this one is more shallow, 2/3. It's not as steep as the parent function. And that's because 2/3 is less than 1. This is all going to come back full circle for graphing our parabolas. Then the negative changes the direction, right? So instead of it being an increasing function, it's a decreasing function. All right, little review on lines. If that is not sufficient, if you're like, whoa, I need a lot more, please feel free to look up another video, maybe a Khan Academy video or something else that you can find on YouTube to help refresh your memory. So we've got a lot of steps here for graphing in vertex form for a parabola. Step 1, identify the vertex, plot and label the point. 2, sketch the axis of symmetry. 3, find 2 more points on the parabola. We're going to use a table for this. 4, reflect those points to find 2 more points, and then finally draw the graph. So example 5, sketch the graph of the function and the axis of symmetry, and then underneath it says we're going to draw the graph solid and the axis of symmetry dashed. So friendly reminder, we're going to draw the graph solid and the axis of symmetry is going to be dashed. And part of your homework assignment on this asks you to do the same thing. Step 1. I need to find the vertex. I'm going to do that by comparing my equation for a quadratic in vertex form to the example given for this problem. Okay. So I'm going to pluck out the vertex. The vertex, this special name HK, it's still a point XY. It's just, we call it HK because it's a special point. It is the vertex. So to get that, you'll notice right here that this minus H, I'm basically going to take the opposite of 2. So I've got negative 2 for my X value, and then the Y value just rings true. So I'm going to have negative 3 here. Okay, so my point is going to be negative 2, negative 3. Just like before, I'm going to draw my X and Y axes. And with numbers like 2 and 3 and an A equal to 1, this graph isn't going to be too big. So again, I'm going to count by ones. So this is 1 and 2, 3 and 4, 5 and 6. So I plot my vertex, negative 2, negative 3. So this is X is negative 2, so I go left 2, Y is negative 3. It asks me to label it, so I'm going to do just that. Now, part 2 asks for the axis of symmetry. The axis of symmetry is just a line that goes vertically through the vertex. So here's my vertex. I'm going to draw a dashed line going through it. There's my axis of symmetry. This next part might be the part that's the trickiest to get the hang of. Find 2 more points on the parabola. So I'm going to make a table. If we think back, or if you flip back in your 3.1 notes, you'll notice that we made some notes about the symmetry of the table for a quadratic also. We're going to recreate that here. In the very middle is going to be your vertex. So leave a little space above, a little space below. What's the X value of my vertex? Negative 2. What's the Y value? Negative 3. That gives me the point negative 2, negative 3. Boom. Okay, the next thing that we're going to do is I need to find some other points. So I'm at this point negative 2. I want to pick 2 points to the left and 2 points to the right. So to the left is going to be negative 3 and negative 4. And then to the right is negative 1 and 0. I'm going to plug those in. Now, because my graph is symmetric about the line of symmetry, I can pick to either plug in -3, -4, or -1 and 0. So you can pick. Personally, looking at these numbers, I would rather plug in -1 and 0. So that's what I'm going to do. So I'm going to plug in f equals f of -1. A reminder, this is just a notation. That means f evaluated at -1. So what I'm going to do is on the right side of my equation is I'm going to plug -1 in for x. And then I'm going to simplify everything on the right-hand side. So order of operations, here we go. I have to do what's inside parentheses first. -1 plus 2 is 1. 1 squared is 1. -3 gives me -2. So when I plug in -1, I get out -2. What's that coordinate? -1 comma -2. -1, -2, make a dot. Then I plug in 0. So I replace the x with a 0, 0 plus 2 quantity squared minus 3. 0 plus 2 is 2. 2 squared is 4. 4 minus 3 gives me 1. So I get the point 0, 1. Now, there's symmetry about this vertex. So whatever is 1 unit away below is also going to be 1 unit here. And then whatever's here is underneath is going to be 1. So these are going to be the same. So I also have the points -3, -2, and -4, 1. That just means it's less that I have to plug into my table. So I am good with that. I'm just going to use that to my advantage. Then I draw the graph. There we go. There's our first parabola. So, example B, very similar. I'm going to do it much the same way. First thing first, here is my equation for vertex form of a quadratic. And the first thing I need to do is find my vertex. So the vertex, x minus 1, x minus h, so h is 1. You just take the opposite, and then this one rings true. So then y is 1. So my vertex is 1, 1. Now, I know what this graph is going to look like ahead of time, so I'm going to take advantage of that and I'll explain. But I am going to draw my axes of symmetry not in the center. I am going to choose to move my axis down a little bit. And that's not something that you would recognize right off the bat because you don't have a lot of experience graphing this, but take it for granted now, and I'll show you why when we're done. With numbers like 1s and 2s, I feel pretty confident that I can fit this if I count by 1 unit, so I'm going to do that. And I graph the vertex. The second step is to draw the axis of symmetry. So I find the vertex and I just go straight through it. Please make sure it's dashed. It's actually not part of the graph, but it is part of finding my solution. Step 3, make a table. If this video is going too fast, feel free to pause. Feel free to also, you can slow down the speed, so that can be really helpful. So I'm going to make a table. I have x and I have g of x. Remember, that's just y. And then I have the coordinate. Instead of writing it x, y this time, I wrote it x, comma, g of x, because g of x and y are the same thing. Now here we go. In the middle of my table, so I want to leave one line, leave 2 line, and then in the middle I want to write down my vertex. So when x is 1, y is 1, and I get the point 1, 1. To fill in my table, I need to pick 2 points to the left and 2 points to the right. So I kind of like to use my graph over here as a little bit of a guide. So if I go 2 to the left, I get 0 and 1, or 0 and negative 1. And if I go 2 to the right, I have 2 and 3. You can plug in whichever pair you want, negative 1 and 0 or 2 and 3. So it depends on where you're at. I like plugging in 0 because I think it's easier, but if I plug in that one, I also have to plug in a negative number. Or you might choose 2 and 3. I'm going to go for the negative 1 and the 0. So I want to plug negative 1 into the g function. So I replace the x with negative 1. Okay, here we go. Order of operations. I have to start with what's inside the parentheses. Negative 2 minus 2. I'm sorry, negative 1 minus 1 gives me negative 2. I'm getting ahead of myself. Then order of operations says I do exponent. So negative 2 squared gives me 4. Then I multiply or divide. And then finally I add. So when I plug in negative 1, I get 9. Negative 1, 9, that's this point way up here. So now maybe you can see why I didn't put my x-axis in the middle, because I wanted that point to fit. So I was just being sneaky because I already knew what the graph was going to look like. Okay, so then I plug in and I evaluate at 0. Zero minus 1 gives me negative 1. Negative 1 squared is 1. 2 times 1 is 2. I add, I get 3. So I get the point 0, 3. So if 1 to the left is 3, then 1 to the right is 3. And if 2 to the left is 9, then 2 to the right is 9. So I also have 2, 3, and 3, 9. So 2, 3, and 3, 9. And I combine all of those to make a graph that looks like a U. Parabola. When we talk about how the shape of A and B look different, it's subtle, but it's there. A is a little wider, so A has an A value of 1, B has an A value of 2. So when I have an A value of 2, that's going to get a little narrower than the original function. And C is different yet because C has negative and it has a decimal less than 1. Feel free to pause and take a breather if you're not ready for this one. I'm going to jump right into it. I like to write down the equation or the formula for vertex form of a quadratic right there so that I don't make any mistake. The x-coordinate of my vertex, the h value, is always whatever I add and subtract here to x. But I don't add and subtract anything here to x. So it's going to be 0. My k value is 4. Let's see, 0, 4. That's going to bring me up 4. But because it opens down, I'm going to have enough room. So 0, 4, here's my vertex. Okay. My axis of symmetry just goes through the vertex. Create a vertical line. I haven't been writing the equations of these. It didn't ask me to, but I could. Right? That's x equals 0. The one up here is x equals 1. Now, I need more points to be able to know what this graph looks like. So I make a table. Here's my x values in the first column, my h of x values, or my y values in the second column. And then I just like to write my coordinate nice and neat and organized in my third column. Write down the vertex first. The x value is 0. The y value is 4. And I'll pick 2 points to the left. -1, -2. And 2 points to the right, 1 and 2. Now, personally, I would choose to plug in the positive numbers instead of the negative numbers, just because I think there's less room for error. But, to each their own. Do whatever you want to do. So I am going to plug in h of 1. So I replace the x with 1, and I evaluate the right-hand side. Order of operations, since I got to do the exponents first. 1 squared is 1. Anything times 1 is just anything. So now I have -0.5 plus 4. And that gives me 3.5. Oh, a decimal. Yes, it's a real number. It's okay. 1, 3.5. Over 1, up 3, and I'm going to put it right smack dab in the middle between 3 and 4. Let's plug in 2 and see what happens. 2 is an even number. It might turn out better. Two squared is 4. -0.5 or -0.5 times 4 gives me -2. Plus 4 gives me 2. So now I've got the 0.22. Okay, whatever happens on one side happens on the other. So I also have -22 and -13.5. So this is just going to be a mirror image across the axis of symmetry. All right. And this should look quite a bit wider than the previous ones because I'm multiplying by 0.5. So notice the negative, right, causes it to flip. It opens down. And the 0.5 should cause the graph to look wider. Okay. An additional thing that I want to point out. At the end of our 3.1 notes, I talked about a way to recognize A sometimes that makes our life a little easier. So let's go back, and I'm going to go back through A, B, and C and look at that. Now, in problem A, this value right here, A is equal to 1. Briefly discussed that the first point sometimes can very easily be found because when I go right one, I go up whatever A is, and A in this case is 1. That gets me to my first point. Sometimes it's an easy way to get a quick graph, or at least a sketch. So B, my A is 2. When I go over 1, my first point is up 2. And C, when I have 0.5, I go over 1, and because it's negative, I go down 0.5. And now, if I were graphing this and had to write the equation, I wouldn't exactly be able to tell that it's 0.5, but it can give me an idea, and it can be very helpful in your assignment when you're working on this. So what I want to do now is I want to show you a possible problem from your homework so that I can show you a little bit about how this is going to work for this graphing. Now, these problems vary a little bit. This one says sketch the graph of the function. There's another one that says sketch the graph of the function and the axis of symmetry, and it will give you specific step-by-step on kind of how to do that. So we're going to graph this, and when I graph in Desmos, there's less to figure out. So I'm going to go ahead and I'm going to click this, and it's going to set me up with a graph and with some instructions. Click the graph. Choose a tool in the palette and follow the instructions to create your graph. Now, all I'm doing for this problem is sketching a parabola. So I am going to select the parabola tool. Then it says, click the graph to plot the vertex of your parabola. I want my parabola to be solid, so that's automatically going to be selected. So the first thing that I need to click on this graph is the vertex. So go back and look at the equation. The vertex should be the opposite of this number, so 1 and then 3. So 1, 3, over 1, up 3. Here we go. So I'm going to put a point right here. Okay, it's going to pop up in that yellow bar on the right-hand side. You picked 1, 3. Then it says, click the graph to plot a point on your parabola. I just need one other point. Now, you can make a whole table and get all the points, but I need one other point for this assignment. So, A value is 4. So from here, I'm going to go over 1, up 4. You'll notice that in the yellow box on the right-hand side, it says 2, 7, and that looks about right. So I'm going to click there, and it'll turn it yellow. Now, I can drag this around. I can pick this up and I can move it, or I could delete it and start over. If it asked me to add the axis of symmetry, then I would pick a line and do dashed and then add in the axis of symmetry also. It doesn't ask for this problem. Then you click save, and then you would check your answer. How'd I do? Excellent! Okay, so there's a tip for your homework. Great. All right, we're going to do one more problem. So, the graph represents a quadratic function. Write the function in vertex form. So, first thing first, get your vertex. So my vertex is -2, -5. And I know that that is HK. So I'm going to plug that in. I'm going to leave a spot for the A right now. Then I have X minus H. So minus -2. I'm going to come back for the A. And then plus K. So plus -5. When I clean that up a little bit, minus -2 turns into +2. And then I have a -5. Okay. I need to find A. Now, there are different ways to do this, and we're going to get into a more complicated way when the problems are a little less, well, let's say this. I'm going to get into a more accurate way when the problems are a little bit more complicated. For this lesson, this little A trick is just going to work where I just count. Okay, so if I just go from the vertex, the next point over is up 1, up 2, up 3. It opens up, so I know that this is going to be a +3. Okay, for this assignment, this is going to be sufficient. Okay. All right, and that wraps up the notes for 3-2. The next set of notes that we're going to be doing is more quadratic functions, more graphing. It's just going to be doing it in a different form. So yeah, so we've got a lot more quadratic fun to be had. All right, thank you very much.